All right, so we're going to start chapter 4. We're starting by using graphs to relate two quantities to each other. So like time to distance or times to volume or two things related to each other. So as a warm-up, look at these graphs and try and match them to the shapes and then think about why. All right, so we have two straight lines. So this is the volume is then relating to the height of your shape. So two straight lines, so these two probably have to go with these ones where it's just straight going up and down. There's nothing weird happening. But this one curves right here, so it probably goes to this one where we have a change in the volume shape. So this one is going to go with this graph. Now we need to think here, this is the height, right? We have a tall one here, we have some height here, we have a short one here, and still height. This one reaches a pretty high height. This one only reaches a pretty short height. So the short one needs to go with the short height, and the tall one goes with the tall height. All right, so some more graphs. Here's a graph. It shows the volume of the air in a balloon as you blow it up. So you're sitting there with a balloon and you're blowing it up, and this is the graph of what happens. So this would be like 0 to say 4 seconds, and volume is increasing as it gets bigger and bigger. So what variables are being compared? The time and the volume. So there's going to be the two axes or the two edges of your graph. So time and volume. Time is going to be your independent variable because time doesn't depend on anything else. Like seconds just keep going by, time just keeps going on. And then volume is your dependent variable because as time increases, your volume would then go up or stay the same or do something different. So now we want to look at points 1, 2, 3 on this graph and figure out what's happening at each point. So you look here at 1. Well, it looks like as time is increasing, our volume is also increasing. So the volume is increasing or going up. Now at 2, if we look at this chunk right there, well, as time's increasing, the volume's not doing anything, it's just staying constant. So your volume is constant or the same. And then here at 3, we have this huge drastic drop, so the volume's going down to 0. So if we think about in real life, well, what's actually happening in this situation? Well, right here, we're probably blowing in to blow up the balloon. Right here, we're flat, so you're probably holding it and taking a breath. And then here, you probably let go, and the air went up and spread out really quick. So another graph here. This is Mr. Lucan's cell phone bill. So I want to figure out what's being compared again. So one axis is the amount of data. So that's 1. And then the other axis is the cost. Your x is going to be your independent. I'll rewrite that. And then the cost will be your dependent variable. If we add some labels to these axes, let's say that this is like $50 right here, and this is at 12 gigabytes. So if we describe this relationship, here we're starting anything from 0 up until this point, whatever that point is, costs $50. It's the same cost. So from 0 to 12 gigabytes, cost is constant. And then from here on, we start going up. So 12 up, the cost increases as the gigabytes or the data used increase. All right, so some more matching. Here we have a table. It's talking about video downloads. So a band posts a new music video and then people download it from whatever their website is. On day 1, they have 346 downloads, and then increasing from there. And day 4, they have 10,000 downloads. So we want to figure out which one does this match with. Well, here we have days and downloads, but the downloads are going down, so that's not possible. There's no way that's going to work. This one here, they're going up at a constant rate, so it'd be like 10 more, 10 more, 10 more, 100 more, but we're going from like 700 more, a couple thousand more, lots of thousands more, so that one can't work. Here we have something leveling off. So we're starting with amount, we have a bigger jump, smaller jump, smaller jump. That one doesn't make sense because again, we're adding more as we go. So we're left with B, where we're growing faster as the days grow up. All right, same idea here. So we have the amount of sunscreen remaining in a bottle after you use it. So the first time you use it, it starts out with 5 ounces. Well, these all look like they start about 5, so that's fine. And then we're going down from there. If we subtract, we're going down 0.2 each time. So we're a constant rate of change. 4.8 minus 4.6 is 0.2, etc., etc. So we want something that's constantly going down, not like curving or going faster. So both of these curve, that's not going to work. So it's going to have to be A. So if you're going to write this on a test or explain this, you'd say you think graph A matches the table because, and then explain why. So one explanation could be as the number of uses go up, so this down here, the amount decreases or goes down slowly. So it's going down slowly instead of here dropping off right away, or here evening off, and then you just have infinite amount of sunscreen. So now, instead of matching, we want to sketch the graph. So we have a model rocket rises quickly, so that's one chunk. Then it comes to a stop as it runs out of fuel, second chunk. So you have 1, 2. Starts to fall quickly until its parachute opens, and then it falls slowly. So we have 4 different things we need to graph. This is 3 and 4. So rising quickly, I'm just going to draw something rising quickly. Stops, would be number 2, and then falls slowly. So I'll make this rise even faster to make it more obvious. So we're rising quickly, we stop, then we fall quickly, and then the parachute opens, and we fall slowly. So this would be your 1, 2, 3, 4. And that's it for this section. Go on to Math Excel and do the 4.1 assignment.